Hello, everyone. Thank you very much for the introduction, moderator. My name is Bruce Wilson, and today my talk will be on robots, residents, and flat whites, brewing warmth in the age of AI. And this is broadly on the topic of how we can better prepare case designs to improve our knowledge of human-robot interaction in the wild. And the goal of this talk today is to tell you a little bit about our deployment and how we use our prior knowledge to our advantage. But just first, a little bit about me. I'm currently a penultimate year PhD student at the CDT RAS in Edinburgh at Heriot-Watt University, and my research interests are broadly in human-robot interaction and how we can use narrative in these human-robot interaction tasks. And I'm also a research associate on the AMPER project, which is looking to encourage reminiscence therapy for older adults with Alzheimer's disease and their carers through the use of a virtual agent or a physical robot. But a lot of the projects I've done in the last couple of years tend to involve a Furhat robot. This is for robot direction givers, for doing these robot reminiscence tasks, or also robot receptionists. But specifically, I tend to have looked a lot at robot baristas. And when I joined the first project back in 2022 as an intern, they were looking at how robot and human personality interacted in an online study. And we found that both introverted and extroverted users preferred a robot with the robot to have an extroverted personality. But this was an online experiment and it was very manual, so we decided to do an in-person, in the wild experiment. In our university common room. And we were asking the question of what influence users trust in a common room service robot. And we found that trust in the common room robot was correlated with perceived usefulness, adaptability, and likability. And we learned a lot of other lessons from this paper as well. And I'm drawing some of these from the Feeding the Coffee Habit paper that we wrote. And this was broadly split into two categories. First of all, the technology, which was a little bit easier to fix. Simple tasks like scanning the loyalty card with a rigid robot with very little ability to adapt to unclear instructions made simple tasks quite difficult. Similarly, with machine learning bias, accents, races, ethnicities, heights, these all exist in real life, and it is our job to account for this in every deployment and making practical choices to make sure that this works. Similarly, with robots use, they're often not designed to be used for every day for many hours, and practical difficulties such as overheating can occur in the right conditions. But these are all technology related. Most of these are kind of fixable. However, things that are a little bit more tricky to face are how people actually interact with the system. And first of all, users' patience. Once the user has received what they wanted, it can be difficult to make them stay for the whole remaining pre-programmed interaction. And users will leave unexpectedly, and they may be interrupted midway through, and the system has to be able to account for that. And similarly, with unexpected usage patterns, participants may not follow the signage completely correctly, and thus might miss important steps to sign up or to give feedback. And again, we have to be able to account for this. Finally, with attrition rate, users have to be motivated to keep coming back and willing to provide feedback so that we can improve the system and they feel that they can improve the system as well. But every single one of these lessons that we've learned influences how we develop our next system, which is the Robot Barista 2025 project. And this project has been deployed in a community bistro down in Stockton in England, and it is in partnership with the North Star Housing Group and the National Robotarium. And the place that we deployed it is in an over 50s housing complex. And similarly to the previous system, we're using a Furhat robot. We're also using a Bluetooth connected coffee machine, and we're using RASA, and it's still an in the wild experiment. And here it is. So there's a couple of adjustments that we did make based on the previous system, but we had a whole new set of design requirements based even separate to our lessons previously learned. Similar, well, looking at our user group and using the practicalities of our deployment, we had to ask ourselves a whole new set of questions. For example, as this was an over 50s home, we had to make sure, what if there are users with carers? There must be a little bit of multi-party interaction. What if there's users in wheelchairs? We have to make sure that we can see appropriate heights and make sure the font is large enough on the tablet screen, make sure the robot is loud enough, not just for users' hearing, but based on the acoustics in the room. Previously, our deployment was just in an office situation where users would leave their loyalty card in their office, but this time it's very close to people's homes, so they may accidentally be washed, may have things spilled on them, so these loyalty cards have to be strong enough to withstand a lot more. This robot is deployed down in Stockton in England, whereas we were up in Edinburgh, so it was about a 3-hour travel to get there, so we had to be able to monitor, fix, and keep the system stocked up from that distance. So we asked ourselves these questions and then kind of based our design focus around this and looking at 3 main areas. First, on increasing accessibility, we had to make sure that all participants sign up, consent, data gathering, and everything was now through the tablet system, and it was integrated at points in the interaction, which actually made sense. For example, while the coffee machine is brewing the coffee, it's too loud to actually have the verbal interaction with the robot. So it's a perfect time to hand over to the tablet where they can then click buttons on the tablet and give us some feedback. Similarly, there was a couple of components that we needed to improve the reliability of, looking specifically at the QR code scanner. A more QR code scanner is something that you would find in an actual coffee shop, and a more modern QR code variant, which scanned more reliably. Previously, we relied on the Furhat onboard camera, which worked well, but the problem was if the user held the QR code too close to the camera, it would obscure the user's face, and the robot would lose tracking of the user. Whereas this new QR code scanner was completely separate and was what you would find in a regular coffee shop. And finally, in terms of placement and practicality, we can't directly control the system that finds users' faces or recognizes their accents, but we can make practical choices that makes those systems more likely to work as intended. For example, making sure the user's face is lit, making sure that the user stands far enough away from the robot, and making sure that based on the room acoustics, the microphone is actually going to be picking up something useful. And that there's enough clearance around the robot that if it's a very warm day, it was next to a window, that the robot wasn't going to overheat and have any issues. So all of these changes aim to nudge difficult to fix problems like attrition rate in the right direction. And overall, the system had quite a lot of moving parts. But it had three kind of main components. First of all, the Furhat robot, which was handling the automatic speech recognition, the text-to-speech, turn-taking, and user engagement. We then passed off to a laptop running Rasa Conversational AI to do intent classification, accent prediction, logging, and most importantly, it was able to send the commands over Bluetooth to the coffee machine, as we had to decompile and do a lot of reverse engineering to make the connection between the Bluetooth coffee machine and any other device work. And then finally, we had the actual coffee machine, which was doing the coffee brewing. But what about the data that we were trying to collect? Obviously, key to this was my PhD area of narratives, which is relating to the fact that in a human-to-human interaction, we'll often share a story alongside an expository response to add a little bit more personal information to and our unique experiences to what we say. And when used in a task environment, these narratives can have exploitable measurable effects, such as on memory recall or interaction engagement. We decided to try and introduce that into the robot as well, and I'm doing that in a couple of my other PhD projects at the moment as well. But in our situation with the robot, we added some facts about the local area, and we also talked about what activities were on for the residents that day. We then adapted these to either facts or activities to either be in a narrative or a non-narrative format. And when I say a narrative format, I mean that we have a sentence or multiple sentences linked together by event chains. And those are either temporal, causal, or spatial. So we're referencing time, we're referencing something in an environment and space, and a sort of cause and effect chain. And when you have all of those three chains, or at least some of those chains together, we tend to call that a narrative. And narratives may play a key role in helping these longer term interactions, especially in the wild, as they may make the robot more adaptive to the user's needs. And that's based on some of my previous research as well. But from that, we're looking at three kind of main research questions, looking at engagement with the robot, seeing whether people are more likely to come back based on the narratives, whether it will adjust their attitudes or perceptions of the robot, that's social perceptions and negative attitudes, and whether it will introduce any recall differences in terms of whether they're more likely to remember facts or remember activities that are on that day. And overall, after the 6 weeks of the deployment, and it obviously just ended last week, so we haven't analyzed any of the data yet, but we had over 50 coffee orders. We had about 39 participants sign up, and we had about 10 repeat customers. And this was very good, but we did notice, just based on some initial analysis of the data, that people would often come up and only get a single coffee and then would not come back. And we're trying to understand a little bit more about why that happened. We're currently doing interviews with staff and waiting on qualitative feedback coming back from the participants as well. But finally, where is the robot going next? Obviously, first steps first, we want to do all of our data analysis and understand a little bit more about how users interacted with it and how staff also felt that users interacted with it. And from that, we'll get a lot more lessons learned. We'll understand more about the usage patterns, and we'll understand more about how the actual interactions took place. Then the plan after that is potentially to update, redeploy, and put the new, more reliable system in another location again. Thank you very much. That's everything from me. I'll now pass you on to Dr. David Robb, who will answer any questions for you. Thank you very much.